Hello friends, welcome to physics class. In our previous video, we have discussed wave equation, how to write a wave equation. There we come across different variables and constant values, time period, wavelength, amplitudes, phase, how to measure the phase, what is phase difference. These things were discussed in our previous class. So in this video, we are going to discuss the principle of superposition of waves. The principle of superposition of waves. What is superposition? Superposition is simply the overlapping of waves one over the another. When two waves are traveling either in the same direction or in opposite direction, when they overlap to each other, that is called as superposition of waves. Once we will see the principle, then after we will go to the explanation. Once you read, when the pulses overlap, the resultant displacement is algebraic sum of the displacement due to each pulse. When the pulses overlap, the resultant displacement is algebraic sum of the displacement due to each pulse. Let us come across this one. What are pulses? What does it mean by pulse? See, this is the equilibrium state of a wave. I am drawing a wave. This is one wave, right? In this is called as one pulse. 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 So when pulses overlap, this is one pulse. These are the pulses of one wave, and here I will draw another wave. This is another wave. Okay now, and these are the pulses of the another wave, right? When the pulses overlap. When does they overlap? For example, this wave is traveling in this direction and this wave is traveling in this direction. Then what happened? These two waves overlap to each other. These two waves overlap to each other. So what is happening when they are overlapping? When the pulses overlap, the resultant displacement. What is displacement here? Imagine this is the displacement of one wave. This is one wave. And I am naming this wave as the y1 is one wave, and here this is another wave, y2 is another wave, right? Y1 is one wave, y2 is another wave. Y1 wave displacement is 3 centimeters. Y2 wave, its displacement is, imagine, 2 centimeters, right? Its displacement is 3 centimeters, its displacement is 2 centimeters. When these two overlap, then the resultant displacement is the algebraic sum of the displacement due to each pulse. What is algebraic sum? Generally, when we are discussing, when we discuss about forces, we come across this word algebraic sum. Algebraic is sign dependent. Sign dependent. For example, I have taken an object and applied a force of 2 newtons in this direction and 5 newtons in this direction. What is the net force acting on this object? Then you will say that 5 newtons in one direction. So let us take this as a positive. In the other direction, that is negative. 5 minus 2, this is 3 newtons is the net force acting on the object. Right? This is what algebraic sum. Algebraic sum is sign dependent. Means displacement in one direction, let us take as positive. Displacement in other direction, take as a negative sign. Okay, displacement in one direction positive, displacement in the other direction is negative. Now see, this is one wave, this is another wave. Displacement is 3 centimeter, displacement is 2 centimeters. Okay, these two have overlapped. After overlapping, what is happening? There are two things may happen. Two things may happen. What is that? This is the first wave overlapping with the second wave. Wait, alright. Overlapping with the second wave. This is the second wave. This is the one wave. One wave overlapping on the other wave. This is one. Another possibility. This is the one wave, wave 1, and this is the wave 2. wave 1, wave 2. Wave 1, wave 2. I'll write it neatly. I'll draw. This is the equilibrium state. This is the wave 1 and this is the wave 2. Right? Two things are happening here. One wave and the other wave. Here what is happening? Crest of one wave overlapping with the crest of the another wave. Okay, crest of one wave is overlapping with the trough of the other wave. Crest is overlapping with the trough. Right? Here its crest is overlapping with the another trough. Crest is overlapping with the trough. Crest is overlapping with the trough. So when overlapping is taking place, there is one possibility that crest may overlap with the trough. This is the one. Second thing, when this overlapping is taking place, crest is overlapping on the crest of the another wave. Trough of one wave overlapping on the trough of the another wave. Crest of one wave overlapping on the crest of the another wave. This is the second type of overlapping. Superposition. Superposition is in two ways. One is crest is overlapping on trough. Another one is crest is overlapping on the crest of the another wave. Okay, I think you understood here. Two waves are overlapping. Then what happened to the displacement? The resultant displacement is the algebraic sum of the displacement due to each pulse. Now let us come to the principle of superposition. This principle, its displacement is here 3 centimeters. Its displacement is here 2 centimeters. Right? 3 centimeters, 2 centimeters. Now what happens? Can you guess? The resultant wave due to this overlapping will get a wave which is like this. I will draw a dotted line now, which is like this. Which is like this. Now this dotted line is showing the resultant wave. This dotted line is showing the resultant wave. Resultant wave. What is its displacement now? See, its displacement is 1 centimeter. 3 centimeters is displacement. 2 centimeters, it's 3 centimeters in upward direction. 3 centimeters, it's a crest. It's a trough, downward direction. 2 centimeters. What is the resultant displacement? Algebraic sum of the displacement. 3 centimeters minus 2 centimeters. So 1 centimeter is the displacement of the resultant wave. Okay. And here the second one, second case, what happened here? Crest is overlapping on the crest. Crest is overlapping on the crest. See here, its displacement is 3 centimeters, its displacement is 2 centimeters. Now the resultant wave will be like this. I will draw a dotted line. Now once you see, this is the resultant wave. This dotted line is showing the resultant wave. Here this dotted line is showing the resultant wave. Can you see the difference now? In this overlapping, in this type of overlapping, the resultant wave's displacement is less. In this type of overlapping, the resultant wave's displacement will be high. And this is called as the destructive interference or destructive overlapping. This is called as destructive. Destructive. This is what? Constructive. This type of interference. In our further class in wave equations, wave optics also will get the same discussion. Destructive interference we call this, called as a constructive interference. In constructive interference, the amplitude will be maximum. Here what is displacement? Displacement is speaking about the amplitude here. Amplitude is maximum in case of the constructive interference. Amplitude is minimum in case of the destructive interference. Now imagine these two waves. These two waves are of same displacement, 3 centimeters and 3 centimeters. These two waves are of same displacement. Okay. Every pulse have the same displacement. Here the pulse have the 3 centimeter displacement. Here the pulse have the 3 centimeter displacement. Now in constructive interference, what happened? 3 plus 3, 6 centimeters will be the what displacement of the pulse. In destructive interference, 3 centimeters minus 3 centimeters, 0 centimeters means there is no displacement. There is no displacement. Now you have to imagine here one particle is there here. Here one particle is there. Here one particle is there. And this particle, this wave is pushing in downward direction. The energy which is there in this wave, it is pushing this particle in the downward direction. In constructive interference, trough is overlapping on the trough. Means already downward direction displacement energy is there. Some force is there in the downward direction. Then this wave which is overlapping, this one also will give the downward force. So that what happened here, the two forces are acting in the downward direction. The resultant force will be high. So that what happened, displacement will be high in case of the constructive interference. Constructive, destructive word లోనే ఉంది మనకు. Constructive అంటేనే పెరగడం, destructive తరిగిపోవడం. కన్స్ట్రక్టివ్ లో రెండు వేవ్స్ ఓవర్లాప్ అయినప్పుడు ఏమవుతుంది, రిజల్టెంట్ వేవ్ యొక్క డిస్ప్లేస్మెంట్ ఎక్కువ ఉంటుంది. డిస్ట్రక్టివ్ లో రెండు వేవ్స్ ఓవర్లాప్ అయినప్పుడు రిజల్టెంట్ డిస్ప్లేస్మెంట్ అనేది తగ్గుతుంది. సో వెన్ ద డిస్ప్లేస్మెంట్స్ ఆర్ సేమ్, then what happened, destructive interference లో amplitude ఏమవుతుంది, జీరో అవుతుంది. Amplitude will become zero in case of the destructive interference if the two waves have the same amplitudes. Okay, right, let us come to mathematical approach. Understood better? See, two waves when they overlap on each other, that is called as superposition. When the pulses are overlapping, the resultant displacement రెండు కండిషన్స్ మీద ఉంది. ఒకటి పల్స్ ఎలా ఓవర్లాప్ అవుతుంది అనేది. One is what, crest is overlapping on the trough. One crest overlapping on the trough. Another one is crest is overlapping on the crest. Trough is overlapping on the trough. This is another kind. This kind is called as destructive superposition or interference. And this is called as a constructive superposition. In destructive superposition, resultant displacement or amplitude is minimum. In constructive interference or superposition, amplitude is maximum. Right? Let us give some mathematical approach to this one. Let us give one mathematical approach. What is that mathematical approach? Let y1 x comma t and y2 x comma t. Y is the displacement of a wave. Wave equation ఎలా రాస్తాం అనేది మనం ఇంతకు ముందు వీడియోలో చూసాం. Wave equation y is equals to ax minus omega t. So right, y is equals to a sin kx minus omega t. y1 x comma t and y2 x comma t. These two are showing what, displacements of the two waves. y1 is one displacement, y2 is the another displacement. Let y1 x comma t and y2 x comma t displacements of, what are these? These are the displacements of two waves. These are the displacements of two waves. Okay, now according to the principle of superposition, the resultant displacement y x comma t is equals to y1 x comma t plus y2 x comma t. This is what principle of superposition. Displacement of one wave, the displacement of the resultant wave, the resultant displacement is the algebraic sum of the displacement due to each pulse. y1 x comma t plus y2 x comma t. Right? If we have few more waves, there are not two waves, there are many waves are there. If we have few more waves, then we can write this one as up to yn x comma t, yn x comma t. t. Okay, now let us write the wave equation for this. Wave equation y1 x comma t, I will write like a sin kx minus omega t. What are these terms? Already we have discussed in our previous video. Y2 is x comma t a sin kx minus omega t plus pi. Pi is phase difference. Okay na. ఆ రెండు వేవ్స్ ఒకే రకంగా ఉండాలని లేదు, ఫేజ్ డిఫరెన్స్ ఉంటుంది ఆ రెండు వేవ్స్ మధ్యలో. ఉంటే ఉంటుంది, లేదంటే లేదు. సో దట్స్ వై pi is the phase difference. If there is no phase difference, we can write 0. Okay, pi is equals to 0. If there is a phase difference, then we will write pi is equals to pi or pi by 2 or pi by 4. Like that we can write the phase differences. So y1 x comma t a sin kx minus omega t, y2 x comma t a sin kx minus omega t plus pi. Now according to the principle of superposition of waves, according to the principle of superposition of waves, what I can write? Y is equals to y x comma t, this is the resultant wave, is equals to y1 x comma t plus y2 x comma t, y1 x comma t plus y2 x comma t. So y1 x comma t, this is a sin kx minus omega t plus a sin kx minus omega t plus pi. Okay, alright. Now let us make few mathematical steps. A common, this is sin a, this is sin b. Sin a plus sin b, what is sin a plus sin b? 2 sin a plus b by 2 kx minus omega t plus kx minus omega t plus pi by 2 kx minus omega t. This is a, this is b. Sin a plus sin b, 2 sin a plus b by 2 cos a minus b by 2. Okay, I'll suppose this one as a minus b by 2. A minus b, kx minus omega t plus pi minus kx minus omega t. Kx minus omega t term cancel out. So what do you get? Cos pi by 2. Right? 2 sin a plus b by 2. Here I will write since. Here you can write since sin 2 sin a, sorry, sin a plus sin b is equals to 2 sin a plus b by 2 cos a minus b by 2. Sin a plus sin b formula వాడినాం మనం. వాడేసినాక ఏమొచ్చింది 2 sin a plus b by 2 cos a minus b by 2. a minus b by 2 చేస్తే kx minus kx cancel, minus omega t plus omega t cancel, plus pi is as it is. So plus pi, cos pi by 2. Okay, now right here 2a cos pi by 2, 2a cos pi by 2 sin దీన్ని ఏమని రాయొచ్చు 2kx minus 2 omega t. So 2 times of kx minus omega t by 2 అంటే ఏమొస్తుంది ఇక్కడ kx minus omega t, right? I'm going to do this one here so that I'll write that step again. Then ఎట్లా రాసుకోవచ్చు మనం 2kx minus omega t plus pi by 2. అవునా? అప్పుడు ఏమవుతుంది 2 క్యాన్సిల్. దీన్ని ఎట్లా రాసుకోవచ్చు? ఇంకా సింప్లిఫై చేయాలంటే 2 times of kx minus omega t by 2 plus pi by 2. So 2 cancel, kx minus omega t plus pi by 2. Right? The same thing we are writing here, kx minus omega t plus pi by 2. 2a cos pi by 2 sin kx minus omega t plus pi by 2. Okay na? So what is this one now? This is the displacement of the resultant wave. This is the displacement of the resultant wave. Okay. If, okay, I write the case 1. Case 1. When two waves are in phase, రెండు ఒకే ఫేజ్ లో ఉన్నాయి. ఒకే ఫేజ్ లో ఉన్నాయంటే ఫేజ్ డిఫరెన్స్ ఏది లేదు. ఫేజ్ డిఫరెన్స్ ఏది లేదు అంటే pi is equals to 0. When two waves are in phase, okay, then what happens? Y x comma t is equals to 2a, pi is 0, cos 0 is 1, so 2a sin kx minus omega t. మనం ఫస్ట్ తీసుకున్న వేవ్ ఒకసారి గుర్తు చేసుకోండి. ఏమైంది? ఫస్ట్ మనం ఏం తీసుకున్నాం? y1 a sin kx minus omega t. y2 ఏమని తీసుకున్నాం? a sin kx minus omega t plus pi. రైట్? ఇవి రెండు మనం తీసుకున్నటువంటి వేవ్స్. ఈ రెండు ఓవర్లాప్ అయిపోయినాయి. ఓవర్లాప్ అయిపోయి సూపర్ పొజిషన్ అయిపోయింది. సూపర్ పొజిషన్ అయిపోయిన తర్వాత ఏమొచ్చింది? y x t వచ్చింది. అంటే దిస్ ఇస్ వాట్ రిజల్టెంట్ డిస్ప్లేస్మెంట్ వచ్చింది. రిజల్టెంట్ డిస్ప్లేస్మెంట్ లో ఫేజ్ అనేది 0 అయినప్పుడు, ఫేజ్ డిఫరెన్స్ అనేది 0 అయినప్పుడు ఏమొచ్చింది ఇక్కడ? y x t is equals to 2a. ఇప్పుడు ఏమర్థమవుతుంది ఇక్కడ? టూ వేవ్స్ ఆర్ ఇన్ ఫేజ్ అంటే ఏమన్నట్టు? crust is overlapping on the crust, trough is overlapping on the trough. ఈ కండిషన్ దేన్ని రిప్రజెంట్ చేస్తుంది? crust is overlapping on the crust, trough is overlapping on the trough, again crust is overlapping on the crust. ఇక్కడ ఏమవుతుంది? రెండు పార్టికల్స్, ఇక్కడ ఒక పార్టికల్ ఇక్కడ ఒక పార్టికల్ తీసుకుంటే ఇవి రెండు ఒకే ఫేజ్ లో ఉన్నాయి. రైట్? These two are in phase. Phase difference ఏమైనా ఉందా ఈ రెండిటికి? Phase difference లేదు. Now when there is no phase difference, we say pi is equals to 0. అంటే pi is equal to 0 అయినప్పుడు resultant amplitude ఎలా ఉంది? 2a, a plus a. ఇందాక చెప్పుకున్నాం మనం అక్కడ 3 centimeters ఉన్నప్పుడు ఏమైంది? 3 plus 3 6 అయింది అక్కడ. Similarly ఇక్కడ amplitude ఏమొచ్చింది? 2a. So here amplitude is maximum. Amplitude is a maximum here. Okay na? ఇప్పుడు కేస్ 2, రెండో కేసు తీసుకుందాం. కేస్ 2. Case 2. What is case 2 here? When the waves are, when two waves are completely out of phase, completely out of phase, no, sorry, completely opposite. కంప్లీట్లీ ఆపోజిట్. ఆపోజిట్ ఫేజ్ అంటే ఒకటి క్రస్ట్ లో ఉంటుంది, ఇంకోటి ట్రఫ్ లో ఉంటుంది. ఆపోజిట్ ఇస్ నథింగ్ బట్ పై ఈజ్ ఈక్వల్స్ టు పై. రైట్? పై ఈజ్ ఈక్వల్స్ టు పై. వెన్ పై ఈజ్ ఈక్వల్స్ టు పై, పై ఈజ్ ఈక్వల్స్ టు పై, ఇక్కడ ఏమవుతుంది? కాస్ పై బై 2, కాస్ 90. కాస్ 90 ఏమవుతుంది? 0 అవుతుంది. 0 into this total term is 0. So displacement is 0. Right? Then y x comma t is equals to 0. ఇప్పుడు ఇది దేన్ని రిప్రజెంట్ చేస్తుంది? ఇది కన్స్ట్రక్టివ్ సూపర్ పొజిషన్ రిప్రజెంట్ చేస్తుంది. ఇది దేన్ని రిప్రజెంట్ చేస్తుంది? ఇది డిస్ట్రక్టివ్ సూపర్ పొజిషన్ ని రిప్రజెంట్ చేస్తుంది. దిస్ ఇస్ వాట్ ద మ్యాథమెటికల్ అప్రోచ్ టు ద సూపర్ పొజిషన్ ఆఫ్ టూ వేవ్స్. ఐ హోప్ యు అండర్స్టూడ్ బెటర్. సీ, సూపర్ పొజిషన్ is nothing but overlapping of the two waves అని నేర్చుకున్నాం. ఈ రెండు వేవ్స్ ఓవర్లాప్ అయినప్పుడు రెండు కండిషన్స్ నేర్చుకున్నాం. ఒకటి కన్స్ట్రక్టివ్, ఇంకోటి డిస్ట్రక్టివ్. వాటిని మ్యాథమెటికల్ అప్రోచ్ ఎలా ఉందో తెలుసుకున్నాం. దీనికోసం ఏం చేసాం మనం? ఫస్ట్ y1 y2 అనే రెండు వేవ్స్ తీసుకున్నాం. ఒక వేవ్ ను a sin kx minus omega t అని, ఇంకొక వేవ్ ని a sin kx minus omega t plus pi అని పేర్లు ఇచ్చుకున్నాం వాటికి. రైట్? ఇప్పుడు ఈ రెండు వేవ్స్ ని యాడ్ చేయడం వల్ల కొన్ని మ్యాథమెటికల్ స్టెప్స్ చేసి రిజల్టెంట్ డిస్ప్లేస్మెంట్ ఇంత అని వచ్చేసింది ఇక్కడ. ఓకే, నౌ రిజల్టెంట్ డిస్ప్లేస్మెంట్ వచ్చిన తర్వాత కేస్ 1 ఏం రాసాం, ఫేజ్ అనేది రెండు వేవ్స్ ఒకే ఫేజ్ లో ఉంటే పై ఈజ్ ఈక్వల్స్ టు 0 బెటా. ఈవెన్ పై ఈజ్ ఈక్వల్స్ టు 0, ఈ ఈక్వేషన్ లో పై ఈజ్ ఈక్వల్ టు 0 రాస్తే ఏమవుతుంది, cos 0 is 1 and here you can see when cos 0 is 1, this is 2a. అంటే ఏమైంది ఇక్కడ ఆంప్లిట్యూడ్ అనేది డబుల్ అయింది. తీసుకున్న ఆంప్లిట్యూడ్ a, మనకు వచ్చిన ఆంప్లిట్యూడ్ 2a, ఆంప్లిట్యూడ్ అనేది డబుల్ అయిపోయింది. సో డిస్ప్లేస్మెంట్ ఇస్ డబుల్డ్. సో దట్ ఈస్ కన్స్ట్రక్టివ్ సూపర్పోజిషన్. when two waves are completely opposite in phase అన్నప్పుడు pi is equals to pi beta. if you write in place of this pi by 2, cos pi by 2 90, cos 90 0 into the total term 0. so displacement ఏమైంది, 0 అయింది. so that is what destructive superposition, right? in our next class we'll discuss about standing waves. okay, right, thank you, bye bye.